So now let's move on to where does intelligence come from? There's not an easy answer to this, but we're going to try to talk to you about what we know kind of so far. So brief review of development, we talked about nature and nurture and how both your genes and your environment can play a role in your development, right? So this same concept is true for intelligence too. Some people might be born a little more intelligent, and some people can become more intelligent if they grow up in an enriched environment. So the book tends to focus more on genetic and biological influences, so that's what we're going to discuss. Let's start off with brain stuff. So first off, researchers have shown that intelligence tends to be correlated with brain volume in certain areas. So for instance, the prefrontal cortex, which if you remember back to neuro, is involved in a lot of those complex decision-making, planning, judgments, things like that. So you might be able to kind of see how that might link to some of the deduction and reasoning abilities that define intelligence. But also temporal lobes. You'll remember your temporal lobe is home to a lot of that semantic visual information, being able to categorize objects into faces, scenes, etc. So it could be considered intelligent to be able to categorize and know the names of certain things. However, there's not one specific area for intelligence. So just like how we have a face area, there's not an intelligence area. It makes sense that there's no one area because there's so many forms of intelligence. However, some studies of individuals with frontal lobe damage, so some damage to their prefrontal cortex, for instance, does show some damage to their fluid intelligence. So I want you to make this connection again. Remember how we talked about in the memory lecture that working memory requires some prefrontal cortex. Again, being able to make decisions and plan and think through things, working memory makes sense that it's in the prefrontal cortex, in the frontal lobe. So if someone has damage to that area, they'll have damage to that fluid intelligence, as we talked about earlier, is pretty similar to working memory. However, their crystallized intelligence is fine. So similar to how we kind of broke down in the memory lecture, people who might have a hippocampus intact, but for prefrontal cortex damage, they'll still be able to retrieve long-term crystallized intelligence because they still have hippocampi. So really think about this in terms of like the memory lecture as well. There's a lot of overlap here. Just know that intelligence, working memory kind of capacity is often in the frontal lobe. And one other thing we're going to draw back to memory is that intelligence tends to kind of be described as the ability to have faster neural communication. So we talked about in the memory lecture where memory was in the brain. We talked about this process called long-term potentiation. So the process by which you kind of add more receptors to the postsynaptic neuron, or maybe you add more neurotransmitters with in vesicles in the presynaptic neuron. So intelligence might be, okay, this is an area of the brain that this individual is particularly good at. And they're good at it because the neurons communicate faster with each other in that area. So on a neural level, you can think about this as being the kind of driver of intelligence. We're going to talk about some sex differences in intelligence, or rather, it's important to know there's not really a difference in the average intelligence IQ score of males and females. As you can kind of see this diagram, they tend to have their average right around the same point. However, men tend to show higher variability in their IQ scores. So you can see males kind of have a larger or a flatter kind of curve. So they have more individuals in the tails than females do. Yeah, so as far as specific intellectual abilities goes, you may have kind of heard these stereotypes that, women are better at those verbal tasks, English, words, and being able to detect emotions, whereas men are better at spatial tasks. And although this is not a perfect, this should never be used as some sort of criteria cutoff for someone's capabilities, because there are strong individual differences here. There is some reason to why this might exist. If you think about, why there might be these sex differences in abilities, you can turn to nature and nurture again. So researchers have shown that prenatal testosterone, so these hormones before your birth, male hormones in particular, are correlated with spatial ability. So this could be why males tend to be a little bit better at spatial performance, but also we mentioned in the developmental lecture, females with congenital adrenal hyperplasia, which is having extra testosterone. Those girls would also be good at spatial ability. So it's more of the hormone than it is the gender. But there's also nurture as well. So infants themselves don't show a difference in spatial ability, which tells you that there's maybe a role of expectation. Their parents might kind of unintentionally or implicitly treat them in a different way, maybe giving different blocks or different emotional toys and things to their different children. So there's definitely some environmental influence as well.